Hi, I'm Emily.
I'm Zach, and today we are going to be sharing our experiment on how Tums can prevent acid rain from damaging plants. Before we can go into the details of our experiment, we should take a step back in time, define acid rain, and talk about the implications that it has on the environment.
So, acid rain can take on many forms, such as rain, hail, sleet, snow, and fog. And it is formed when sulfur dioxide and nitrogen gases are released into the atmosphere, react with water and oxygen, and then precipitate back into the ecosystems across the globe. And it typically has a pH of about 4.
Acid rain's existence has not always been as a function of man-made issues such as the Industrial Revolution. It started out originally occurring due to naturally environmental factors like volcanic eruptions, which release toxic gases that react with the materials in the atmosphere to create said acid rain. However, since the dawn of the Industrial Revolution, its negative impacts have heightened due to the increase in the release of fossil fuels into the atmosphere.
Although there has been a reduction in sulfur dioxide and nitrogen oxides emissions with the implementations of programs such as the Clean Air Interstate Rule, Acid Rain Program, and Nitrogen Oxide Budget Training Program, acid disposition is still a prevailing problem. For instance, acid rain can cause a lot of damage to man-made structures like the ones you see above. And other than acid rain, leading to eutrophication in water bodies and harming the growth of fish and shell forming in these acidic aquatic environments, decreasing the pH of the soil can deplete it from important plant nutrients and buffers such as calcium and magnesium, and can release aluminum that bound to soil particles and rock in its toxic dissolved form. The plants having little to no nutrients can prevent its growth and damage the leaves of vegetables such as spinach and cause blemishes on delicate products such as tomatoes. And as a result, the plants won't be able to perform photosynthesis as well, considering their leaves will be harmed, which is where the sunlight is absorbed. And so the light won't be able to hit the pigment in the membrane of the thylakoid. So the plant won't have energy of the sun to change the water and carbon dioxide into glucose and so on.
Likewise, the impacts of acid rain on the environment have substantial effects on organisms' ecosystems. For example, when acid rain strips the nutrients from soil, these nutrients are inaccessible to plants, which cause them to wither and die. When plant species die, animals such as herbivores are then unable to get the energy they need to function as well. In light of the knowledge gained on how acid rain impacts plant growth, we will conduct an experiment that assesses how the utilization of Tums, an antacid, as a buffer in plant soil is an effective method for preserving soil health and maintaining plant health from acid rain. Although this experiment has been done before, we wanted to see how easy it would be to perform in order to assess its practical value and give ourselves a better idea of how acid rain impacts plants.
In order to perform this experiment, we will need soil, water, cress plant seeds, sulfuric acid to create the acid rain, Tums, some protective gear like goggles and protective gloves, pH strips, and pots for the plants.
The plant we will use is cress, which we will grow into 4 different pots. Due to the time constraint that we are limited to for this project, cress will be a good choice since it is fast growing, cheap, and easy to maintain. Each pot will be cared for under different measures in order to effectively measure the impacts of acid rain and Tums on soil and plant health. For example, one pot will be maintained with only water as a control. One pot will be maintained with water and Tums, another will be maintained with just the diluted acid, and we will be using an acid rain, and the last will be maintained with Tums and acid rain. Additionally, we will poke 5 small holes in the bottom of each pot before placing it inside of another pot in order to let the water that we use to water the plants go into the cup and be contained.
After we have planted the seeds in each pot, every day until the cress plants have all sprouted and grown in the pots, we will water them with 30 milliliters of tap water using a 30 milliliter measuring cup. Above you can see me watering the plants.